Hello friends, welcome back to my channel Chemistry with DB. In this video I'm going to explain as to why does boron, which is a group 3 element, shows a lower ionization energy, first ionization energy, as compared to the group 2 beryllium. Now we all know that the general trend across a period for the first ionization energy is that the first ionization energy increases. The reasons for these three reasons are there. The first one is that the atomic radius as we go along a period, it decreases. Okay, so this is the general trend, that the atomic radius becomes smaller. On the other hand, second reason is that the shielding stays the same because same number of shells in a period for all elements. And the third is that the nuclear charge increases due to the number of protons involved. As we go along, the atomic number increases because the number of protons is increasing as well. As a result of these three reasons, what happens is that the nucleus exercises greater attraction for the outgoing electron, and therefore more energy is required to remove this. So this is why first ionization energy increases as we go along a period. However, group 3 elements, for example boron, shows a lower first ionization energy than the group 2. In order to understand why it happens, we need to see it as to the electron configuration. So boron, has got 5 electrons. So the first electron is being removed from a 2p orbital. Whereas in case of beryllium, it's removed from a 2s. Now you know that the 2p is further away from the nucleus as compared to 2s. Also, it has more shielding, because you can see that in case of boron, these 4 electrons are providing shielding as compared to beryllium, wherein only 2 electrons are providing the shielding. As a result of this, what will happen is that less energy would be required to remove this electron from the 2p, right, which is further away and has got more shielding. So as a result, less energy would be required to remove the outermost electron, and this is why the trend is that boron has a lower first ionization energy as compared to beryllium. Now the similar trend appears again in the next period, wherein we see that even magnesium and aluminium are showing the similar deviation. Aluminium shows a lower first ionization energy than magnesium. Again, now applying the same logic, you can see if you will look at the electron configuration. So aluminium, the first electron is being removed from the 3p as against magnesium, where it was going from a 3s. Magnesium being an s block and aluminium being a p block element. Because 3p is further away from the nucleus, and also it has more shielding, because all of these shells are providing the shielding, as against in case of magnesium only these 10 electrons providing the shielding. This is the reason that there will be less nuclear attraction for the outgoing electron in case of aluminium, and this is why less energy being required to remove this first electron. This is why the first ionization energy for aluminium is always less as compared to that of magnesium. I hope this explanation you were able to understand, and if you like this video, then please like, share and subscribe. And in case you would like to have any lesson inquiries, then you can always get in touch with me on chemistrywithdb@gmail.com. Thanks for watching and take care. Bye.